we did for part 3 here, where we did some math. All right, so let's write down our expression that we used to sort of solve for our temperature profile. And so it was negative u times the next time step at the, all the positions at the next time step. So at the position after our current, plus 1 plus 2u, tj n plus 1 minus u, tj plus minus 1, n plus 1. That's going to be equal to u, tj plus 1 at n plus 1 minus 2u, tj n plus u, tj minus 1 n. All right, and so like we did for part 3, we had a particular solution that satisfied the differential. And so what was that particular solution again? Well, it was tj at n is equal to exponential ik j delta x exponential alpha k squared n delta t. And we said that the next positional step, tj plus 1, only varied by an extra ik delta x term, and same thing for the previous positional step, the negative ik delta x. So that's what we said in part 3. Well, for here, we can say the same exact thing for the next time step, where at that same position, the next positional step and the next and the step before that also vary by the same exponential terms. And so we'll plug this in for this current time, and we'll plug this in for the next time as well. So what does that look like? Well, this will have a tj n plus 1 common term that we'll factor out. So tj n plus 1. And so that'll be minus u times e ik delta x plus 1 plus 2u minus u e negative ik delta x. And that's going to be equal to the current time, which will be tj n, right? u e ik delta x plus 1 minus 2u plus u e negative ik delta x. All right, and so we want it in terms of what value will we get at the next time step when we multiply our current time step with some coefficient, right? And so we'll divide this entire term over. So it's going to be equal to tj n. It's going to be multiplied by ue ik delta x plus 1 minus 2u plus ue negative ik delta x. Oops. And that was this divided by this, u ik 1 plus 2u minus u e, oh, oops, that kind of looks like an exponent, e negative ik delta x. All right, and so from here, we can apply what we did for part 3, which was Euler's formula, and we know that the summation of these exponentials will be 2 cosine x, and then x, well, the thing inside, the variable inside of the cosine will be whatever is in the exponent. So simplifying further, we get 2u cosine k delta x plus 1 minus 2u. And then on the bottom, we get negative 2u cosine k delta x, because of the negatives here, plus 1 plus 2u. And so we can factor out the 2u's here to make it look prettier, more clean. We'll see what's going on better. And so up here, if we pull out, we'll have the 1 in front, and then we'll do minus 2u. And so this will be 1, and then minus 2, not 2u, cosine k delta x. We'll have the 1 out in front again, and we'll do plus 2u for this one. So we'll have 2u times, to get this will be 1, and then plus, well, not plus, minus, right? Plus 2u minus cosine k delta x will get us this minus 2u cosine k delta x. And we can see what's going on, very apparent. We have 1 and 1 here, right? Being subtracted on the numerator. So 1 is being subtracted by some value, and then it's being, for the numerator, right? And then for the denominator, it's being added to by that same value. And so what's happening here is that we're always getting a fraction of 1, right? So since these two are the same value, we can just say then that this is 1 minus some value, and then this will be added to 1, that same value. They are the same value, so they'll have the same variable, right? And so we notice that this will always be 1, because if you subtract by the numerator, it's always small, and then the denominator is always increasing. And so this proves that this will always be less than or equal to 1, which is what we want. And so it will never be unstable and go to infinity. And so, yeah, that was basically the analysis there. Another thing I could point out is that since this is this w term will always be greater than or equal to 0. In this case, positive, I guess it will always be positive, since cosine's maximal value is 1. Its maximum value is 0, and so therefore this will always be positive. And so, yeah, and so that's it for homework 4 here. See you around.